Okay, now we're on to the last chapter, sequences. So to find the first 5 terms of a sequence, well, we just plug in 1, 2, 3, 4, 5. So we'll just make a little table. You don't have to do it this way, but when I plug in 1, I get 1 squared minus 1 is 0. 2 squared is 4, minus 2 is 2. 3 squared is 9, minus 3 is 6. 4 squared is 16, minus 4 is 12, and 15, 5 squared is 25, minus 5 is 20. So these would be the first 5 terms. Now you can actually do this on your calculator too. Some teachers teach it and some don't. I do. So how do we do it again? We go to mode. I'm not used to this calculator. Sequence right here. I know that the other TI-84s have the same thing. This just has more options. We go to sequence. Now I'm going to go to y equals. Now our function becomes a sequence now. So our function, our sequence is going to be n squared. So when I choose this, it now chooses the n squared minus n. And I go to the table, and there they are. Now there's errors for the negatives because we don't have a sub -1 or so on. And here we can see 2, 6, 12, 0, 2, 6, 12, 20. So our calculators can answer these for us also. That's kind of cool. And it can help us out with the other problems too. Find the first 6 terms here. Now we can use our calculator. You actually can use your calculator for recursive, but well, let's do it by hand first. So the first 1, 2, 3, 4, 5, 6. And we already got the first 2. That's 3 and 4. That comes from right here. 3 and 4. And now this says just add up the 2 previous numbers. Add up a sub n, which would be a sub 2 plus a sub 1. So 4 plus 3 is 7. Add up the previous 2 numbers. 7 plus 4 is 11. 11 plus 7 is 18. And 18 plus 11 is 29. Now how do we do this on our calculator? Let's see if I remember. We go to this and we delete. We're going to do u sub n equals, now there should be a little u. Let's make this bigger so I can see. U is right there. So it's a second 7. So second 7 gives us the u, and we're going to put n minus, what was it, n minus 2, n minus 1, n minus 2, like that, plus second 7, n minus 2, and we need to tell it the first 2 points. The first 2 points are 3 and 4. So we put 3, comma 4. So it knows the first 2 points. Go to table. Did this wrong. I think we have to put bracket. Second bracket. 3, comma 4 bracket. Table. Yep. So the first one, the first number is So it actually did it backwards. It's actually not going to matter in this case, but to make it clear, we're going to do 4, 3. So I guess that the first, this is the A2 and then A1. And here we have 3, 4, and if you look at, compare 3, 4, 7, 11, 18, 29. It might actually have been faster just to do it by hand, but just so you know that your calculator can solve a lot of these problems for you. Evaluate the sum and round to the nearest hundredth if necessary. Now this is, there's only 4 terms here that we're going to add. We'll do that one by hand. So a sub k, we're going to just write out what these terms are. A sub 3, a sub 4, a sub 5, a sub 6. A sub 3 means I plug in 3 here. 3 squared is 9. 9 minus 5 is 4. 4 divided by 2 is 2. And this I can actually use to solve even this part. So y equals, we're going to clear that and then clear that. We're going to have n squared, so k squared, but it uses n, minus 5, and I should put this all in parentheses. Parentheses n squared parentheses n squared minus 5 divided by 2. And we're going to look at the table. So what I have here is basically 3 is 2, 5.5, 10, 5.5, 5.5, 10, and then 15.5. So we can just add these up. This is going to be 12 plus, this is going to be 21. Looks like it's 33 is our answer. Now, can our calculators do these? Yes, they can. So how do they do that? We go to second, quit. Well, the easiest way, you just add them. There's not that many of them. If we go to, so we're going to use a list. I'm going to make this a little bit bigger so you can see it. We're going to go to list, second list, math, sum is number 5. The sum of, put in parentheses, n squared minus 5 divided by 2, comma, the variable that you're using, in this case n, comma, where you're starting from, 3, comma, where you're ending, 6. So this is the function, the variable, starting, ending. And there's another thing you can use there, it's a skip, but we're not going to use that for now. And of course I did it wrong. I guess it needs a skip, so the skip is going to be 1. We're just going to go up by 1 each time. I guess I got that wrong. 3, 6, 3, 6, 1. And what I did wrong here was what I need to do is sum of the sequence. So sum, it doesn't know, what you put in here is a list, and it doesn't know what this list is. So I gotta make this a list by making second list ops, and then number 5 is the sequence. And let me just start this all over just so we can make better sense of this. So what we're going to do is we're going to make a sequence. Five. Our expression is n. I'll put in parentheses n squared minus what was it? 5 divided by 2. The variable is n. The start is 3, 6. The step is just 1. And so that is the 4 numbers we have here. Now what I'm going to do is I'm going to sum all of those up using 5, sum of the answer. Now you could have put it all in together, but we'll do it in 2 steps. 33 is the answer.